the heat transfer through plane wall. Assume you have a plane wall having thickness of x, material of the plane wall having thermal conductivity k, inner wall temperature is Ti, outer wall temperature is To, and heat transfer area is E. So if Ti is greater than To, in that case heat will transfer from inner wall to inner surface to outer surface. We know Fourier's equation for heat transfer is Q is equal to minus Ka dt by dx, and if you look at this particular plane wall, you will find as we are moving from inner wall to outer wall and increasing the thickness, temperature is gradually reducing. So temperature is a function of thickness. So we'll integrate this particular equation with respect to limit T varies from Ti to To and thickness S varies from 0 to x. Let's integrate this equation. So dx is equal to minus Ka by q dt, 0 to x is a limit Ti To. So after integrating, I'll get x minus 0 minus Ka by q To minus Ti. So I'm rearranging this equation, so I'll get q is equal to Ka Ti minus To by x. So this is the equation for heat transfer through a plane wall. And if this particular plane wall is made of different layers having the different thermal conductivity, in that case let's assume that, suppose this is the plane wall is made of three different material. So uniform thickness, or just say that thickness is x1, x2 and x3. This inner wall temperature is Ti, this one T1, this T2 and this is To. And first layer having thermal conductivity K1, second K2 and third one is a K3, and heat transfer area is A. In that case, by using this equation number, we can say 1, we can write the equation for each wall, each layer separately. So let's assume this is the layer A, or this is layer B, or this is layer C. So let's write the equation. So for a first layer, Q is equal to minus K1A by x1, or we can say, we can write plus in terms of plus. So this is Ti minus T1. This is the first equation. So we'll rearrange. Ti minus T1 is equal to Q dot x1 by K1 into A. This is the equation number 2. Similarly, we can write the equation for this is for A. For B surface or B layer, we can write equation and arrange T1 minus T2 is equal to Q dot x2 K2A. This is equation number 3. And for C, you can say T2 minus To is equal to Q dot x3 K3A. This is the equation number 4. So to get the equation for the composite wall, let's add all the equation. So you'll know this will cancel, this again cancel. So we have Ti minus To is equal to Q dot x1 by K1 A plus Q dot x2 K2A plus Q dot x3 and K3A. So again I am rearranging Q by A. Common term, this is x1 by k1 plus x2 by k2 plus x3 by k3. So now final equation is Q is equal to A Ti minus Tu whole divided by x1 by k1 plus x2 by k2 plus x3 by k3, and this is the final equation for composite wall made of three different material. In case this wall is made of n number of material, then you can say this equation is extended and this is xn by kn. Thank you.